Okay, Assalamualaikum dan selamat sejahtera. So, today I will continue my lecture for Industrial Power System topic 2, which entitled Industrial Distribution Equipment. Okay, this is the outline for topic 2. The first one is introduction, and then we continue with subtopic distribution transformer and reactor, and then instrument transformer, and then switch gear, power cables, protective device, and motor control center, MCC. Okay, so we go to introduction. Okay, main equipment in IPS, first is distribution transformer, and then we have switch gear, and then power cable, and then we have compensation, protective device, and also motor control center. Okay, this is the overview of IPS. Okay, incoming distribution transformer is 132 kV, step down to 11 kV. Okay, this one. This is the transformer. Okay. And then go to main switch gear, 12 kV. Okay, from main switch gear, there are going to switchboard 1, this one, switchboard 1, and switchboard 2. Okay. And then from switchboard 1, there are MCC 1, and also from switchboard 2, there are DB1 and DB2. Okay, this is the intelligent industrial communication and power network concept. Okay, we can see here there are control network here. Okay, there are grid here. Okay, the grid is from transmission, and then go to substation, and then from substation, going from substation is power transformer. Okay, and then this one is the power generation. Okay, so from the transformer, there are this power distribution here. Okay, incoming, this one, and going from the power distribution is to the distribution transformer here. Okay, or also direct to the medium voltage process motor. This one is for motor with heavy load. And from the distribution transformer here, okay, outgoing to system drives, and also motor control center here. Okay, so from motor control center, there are single device here, and then there are instrument here, there are quality control here. All are interconnected each other and controlled by network here. Okay, this one, there are server here, and then there are energy management server, there are power distribution server, information server. Okay, all controlled here. Okay, this is the distribution transformer overview. Okay, we have main parts here, core and magnetic circuit, thin and cold, roll again oriented steel lamination, and then we have winding, either copper or aluminium here, winding. Okay, and then we have tank for liquid. Okay, this one for tank for liquid. Okay, this one is oil. Okay, depends on the types of liquid. Okay, tank for liquid is immersed transformer and an enclosure for dry type transformer. Okay, basic core and coil configuration, core types. Typical type in distribution transformer. Okay, this one. Okay, we have red, 3 winding for red, yellow and blue, 3 phase. So this one is coil. Okay, this one is flux from the magnetic, and then this one is the laminate steel core. Okay, next we go to the construction of distribution transformer. This one is for shell type. Okay, developed for very high magnitude short circuit applications such as generator, step up, transformer. So this is the construction. Okay. Okay, next we go to distribution transformer tap changer. Okay, tap changer in distribution transformer. First one is off circuit tap and load tap changer. Okay, usually placed on the primary winding in order to minimize the current to be switched as larger current is energized at secondary in distribution transformer. And then off tap is used in industrial power system with 4 full capacity taps. Okay, 5 position on primary HV in which provided 2.5% per step. Okay, the transformer must be de-energized before the tap changer mechanism is open. And then the second one is load tap changer. Okay, LTC are usually used with oil immersed transformer connected to the utility power supply. Okay, at a voltage level exceeding 34.5 kV. Okay, typical voltage variation is plus minus 10%. Thus, the tap changer is provided with an equivalent range of voltage regulation of plus minus 10% in 16 or 32 steps. What is the percentage per step for each type? Okay, so we know this is we continue with distribution transformer types. Okay, types of distribution transformer. Okay, the first one is oil filled immersed, non-flammable liquid filled, and dry types. First, we go to oil filled. Okay, this is the structure for oil filled. Okay, this one we can see here. Okay, this one. Okay, you can see here. Okay, this one is the oil tank. Okay, oil converter. This one, and then oil indicator. This one is oil indicator. Okay, so this is the tap changer. Okay, this one. Okay, this one is the thermometer, and then this one is low bushing. This one is for low voltage. This one is for high voltage bushing. Okay, oil filled transformer up to 2500 kVA are of 2 types. Okay, there are 2 types of oil filled. The first one is permanently sealed tank. Okay, widely used as maintenance free. Okay, and then the second one is tank with a conservator. Okay, as the winding heats up and cool downs, the air is expelled from or drawn into the transformer through the conservator. It can be repaired at the site. Okay, there are 2 types. Types of oil used. Usually we use mineral oil, synthetic oil, okay, such as chlorinated diphenyl ascaryl and silicone oil. Okay, for maintenance, okay, oil field maintenance. Okay, maintenance of oil field transformer, oil, dielectric strength and acidity should be checked annually. So two types, oil, dielectric strength and also acidity. Okay, if the dielectric strength is less than 50 kV for 1 minute or the acidity is above 0.4 milligrams of potassium hydroxide per gram of oil sample, the oil should be replaced or filtered. Okay, this one is the cooling method. Okay, cooling method in a distribution transformer is designed by 4 letters. Okay, this one. The first one is internal cooling medium. Okay, and then second one is NFD. Okay, this one is for circulation mechanism for the internal cooling medium. Okay. Okay, for AW, external cooling medium. Lastly, for NF, circulation mechanism for the external cooling medium. Okay, this one is the cooling method. Okay, for oil field transformer. Okay, this is the letter. And this is the... Okay, this one is the letter. And this one is the description. Okay, what is meant by all the letters. Okay, different letters will give different types of liquid description. Okay, there are two condition, internal and also external cooling method. Okay, this is the oil field cooling methods. Okay, there are two types that usually used for distribution transformer. The first one is on-off and the second one is on-none. So on-off means all natural air force, and on-none means all natural air naturals. Okay, it means that for on-off, the oil will be circulated without any force measure, but the air will be blown through fans. For on-none, okay, when the oil is circulated in oil fins without any force measured, okay, then it is called all natural and air on the fins goes by nature. Okay, that means by on-none and on-off. Okay, this is the dry type. Okay, we can see here. This one is the 3-phase transformer. Okay, red, yellow, blue. Okay, 3 different types of construction for dry types. The first one is vacuum pressure impregnation in polyester or silicon varnish. The second one is cast oil or cast resin, this one. And then the third one is VPI epoxy seal or encapsulated. Okay, there are 3 types. Okay, for dry type insulation, okay, this is the insulation class. Okay, this one. Okay, this one is the ambient temperature. This one is the temperature rise. Okay, and then this one is the hottest temperature rise. Okay, permitted winding temperature. Okay, this one is the recommendation temperature rise. This one is for dry type. Okay, this is the typical ratings for distribution transformer. Okay, this one is for the primary side, and then this one is the voltage for secondary side. Okay, this is the rating, and this is the construction types. Okay, for each types. Okay, dry versus oil, availability of rating. The first one is availability. Okay, dry type transformer are available in certain ratings only. Okay, cost and location. Okay, oil field is 20 to 30% cheaper compared to dry. Okay, oil field is suitable for outdoor and indoor installation. Dry type is only for indoor installation. Okay, for fire, building or electricity regulations, oil field is restricted to this regulation. Okay, some locations like basement and top floor is permitted to dry type only. Insurance is higher for oil field. Okay, for maintenance, we can see that dry type do not require any maintenance except dust free. Okay, but for oil field, except permanently sealed, needs more maintenance because the oil will be changed. The characteristic of the oil will be changed. Okay, this is the transformer connection and vector group. Okay, we can see here the first one is star connection. Okay, and then we have delta connection and we have zigzag connection. Okay, the first one is star connection. Okay, this is the star connection. Okay. Okay, and the star point of transformer is Y, Y, and O. Y, Y, and 6 vector group can only be used for earthing or for a maximum load that doesn't exceed 10% of the rated current. Okay. Okay, this one is for Z. Okay, transformer connection Z. Okay, in zigzag connection, the current always flow through two leg windings from the conductor terminal to the star point terminal. Okay, we can see here the primary one is the star and the secondary side is the zigzag. Okay, this one is delta connection. Okay, this one is delta and this one is star connection. Okay, the delta connection, each leg require more winding by vector of square root 3 compared to the star connection to attain the same voltage. Okay, for the star connection, the voltage for single phase and three phase is same, but for delta connection, the voltage for three phase and single phase is not same. Okay, next we go to subtopic reactor types. Okay, this one is the type of reactor. Okay, reactor 1, series reactor for fault current limitation, and second one is used to shunt reactors either for reactive compensation or harmonic filter. Okay, there are two construction types. The first one is air core air insulated types, and the second one is liquid insulated iron core types. Okay, for instrument transformer are designed to transform voltage or current from the high value in the industrial power distribution system to the low value that can be utilized by low voltage metering device. Okay, instrument transformer usually used for metering device. So the output or the secondary part of the instrument transformer is low voltage. Okay, 3 primary application for IT instrument transformer. The first one is for metering purpose. Okay, for energy billing and transaction purpose. The second one is for protection control, and the third one is for load survey. Okay, this is the symbol for IT. Okay, this one is the conceptual picture of the current transformer. Okay, this one is symbol of a voltage. Okay, this one is primary side and this one is the secondary side. And this is the conceptual picture of the voltage transformer. Okay, this is an overview of instrument transformer. As we can see here, this one is current transformer, and this one is the voltage transformer. So going for current transformer here is connect to ammeter, and voltage transformer here is connect to voltmeter, and then voltmeter and current meter will connect here to get the watt meter. Okay, here is the explanation. Okay, the current transformer is designed to be the standard value is 5 amp. Here is 5 amp. For voltage 240 for single phase for line voltage, and then B, okay, for B the indicator of the polarity makers. Okay, this one is polarity makers. It shows that the polarity of the makers is the instantaneous direction of the current. This one. So the arrow shows the polarity of the current flow. Okay, this is the potential transformer switchyard. Okay, this is the layout. Okay, and then also the figure. Okay, this is the current transformer picture. You can see here, red, yellow, blue, current transformer. Okay, this one is incoming. Okay, and this one is outgoing. Okay. Okay, next we go to subtopic switchgear. Okay. Okay, function of switchgear. Okay, this is the figure of switchgear. You can see here, switchgear is in the control room of substation. Okay, function of a switchgear is, the first one is protection. Okay, for protection. And then for isolation, I, offsection of an installation, and electrical control. Okay, this one for electrical control, the local or remote switching. Okay, this is the function. Okay, and also the mimic diagram. You can see here there are some items with the diagram. So all the items are in the switch gear. Okay, function of switch gear. The first one is for protection. Okay, protection from the overload current. Okay, the second one for short circuit current, protection for insulation failure, and last is for under voltage protection. Okay, for isolation, switchgear is used to isolate the faulty section. Okay, because there are circuit breaker there and also the load, so that the switchgear will isolate the load from the supply and isolate energized section for maintenance. Okay, this one for maintenance, to isolate the supply, we have to on or off at the switchgear. And lastly, for control, the function is functional switching, for switching purpose, for emergency switching, for emergency stopping, and also for measurement. Okay. Okay, the main component in switchgear. Okay, incoming feeder. There are incoming feeder. And then we have bus bar. Okay, this one, bus bar at the top. Okay, bus bar. And then we have circuit breaker, CB. Okay. And then we have contactor. Okay, this one is the contact inside the switchgear. And then we have fuse. Okay, also inside the switchgear. And then we have isolator or disconnector. And lastly, front panel. Okay, this one front panel for metering or for switching purpose. Okay, this is the basic magnitude in switchgear. Okay, there are voltage. Okay, Okay, rated voltage, and then we have operating voltage. Okay, and then current, we have rated current, operating current, and then we have short time withstand current. Okay, and then peak withstand current. And also we have frequency. Okay, frequency 50 Hz, and also we have short circuit power. Okay, okay, that's all for topic 2, part 1, and I will continue in part 2 for next lecture. Thank you.